Hey, it's Workbench Quagmire back with our free code camp, Python certification in 100-ish days. We are back with our very first workshop in our algorithm section. Looks like we had 2 of those in 4 labs. So looks like they're going to teach us a lot of the different algorithms here in this section. So there was just a very short theory section here we did last time. So let's jump right in to implement the binary search algorithm. It's just 16 steps. I talked about last time, this is like how if you create like a guessing game, like guess a number. If you guess a number from 1 to 10, if you wanted to solve that most efficiently, you would use binary search. So this is going to teach us how to win that game with the fewest possible number of steps. So in previous lesson, you learned about binary search and how it differs from linear search. In this workshop, you'll put that into practice by building a binary search algorithm. To begin, create a binary search function with a search list and value parameters. So we are going to create define binary search. Step 2. The binary search algorithm you're building will not just return true or false to indicate whether the value was found or not. It will also return the path it takes to find the value. For that, you will have a path to target variable to track the path. The binary search function replace the path keyword with path to target variable and initialize it as an empty list for starts. Step 3, in binary search, there is a lowest possible index and a highest possible index. The lowest possible index represents the leftmost boundary in the current portion of the values being searched within this case, search list. The highest possible index, on the other hand, represents the rightmost boundary in the values being searched. To account for those two, you have to consider the entire list being searched. So inside the binary search function, define low variable with a value of 0 and high variable with a value that accounts for the last index in the list being searched. And so we talked about the last index before. So low equals 0, and then high is going to equal the length of the search list minus 1. Because if we're searching a list of 10 items, the indices run from 0 to 9. There we go. Step 4, now that you've defined the boundaries of your search, it's time to create the loop that will perform the binary search algorithm. Binary search works by repeatedly narrowing down the search space. The process continues as long as there is a valid range of elements to check. If you express this with a while loop, that will continue as long as your low pointer is less than or equal to your right pointer, your high pointer. This is where it gets dangerous. While loops are dangerous. So, while low is less than or equal to high, if the low value becomes greater, it means the search space has become empty and the value is not in the list. Inside the binary search function, create a while loop with a condition that checks if the low is less than or equal to high. Inside the loop, use pass. There we go. Step 5. To get started with the loop, you need to find the middle index of the current search space. We have mid. You can get the middle index by calculating the average of the low and high variables. You will have to use floor division to get the average after adding the 2 values, so the answer will always be an integer rounded down, as the indices must be an integer. Remove pass keyword from the while loop and create a mid variable set to the average of the low and high. So we take low plus high, and then floor division 2. Now that you've calculated the mid index, you need to actually retrieve the value from the search list at that index. This value is what you will compare against the value parameter, which is the target you are searching for. So create a value at middle variable. and assign it the element from the search list that is located at mid. So search. Step 7. Now include the value at the middle in the path to target list to track the steps taken during the search, regardless of whether it's the target. So we just want to append this to target dot append value. Middle of the path to target list. Typo. Step 8. The next thing to do is to create a condition that will check if the target value is in the middle. Inside the while loop, create an if statement that checks if the target value is equal to the value at middle. If it is, return the path to target variable. Step 9, you need to test out things so you understand the flow of the algorithm at this initial stage. To do that, you need to first break out of the loop. That's because the current implementation will only allow one iteration. So if the condition is not met, there will be an infinite loop. Just after the if statement, use the break keyword to break out of the while loop. Then after the while loop, return an empty list signifying that the value was not found. So, break. Be reminded that the function takes a list called search list and value you're looking for. Now, call the function with binary search 1, 2, 3, 4, 5, searching for 3. And binary search 1, 2, 3, 4, 5, 9, searching for 4. And we want to print these. So you see there, the first one, we found 3. Immediately, because that was the mid. And then nothing is returned, even though 4 is in the list, because it's going to go look at 3 again. So 0 to 5, the mid of that's 2. So it's going to look at there and say, is 3 equal to 4? No, it's going to break out and return an empty list. You can see the first call returns 3. That's because 3 is in the middle value in the list. That's what I just said. On the other hand, the second call returns an empty list because it's checking in the middle. Blah, 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 blah. It only acts as a single midpoint check and finishes without further searching. To allow the binary search to continue narrowing its search, add an elif block that checks if value is greater than value at middle and add pass. So, elif the value is greater than value at middle, pass. Okay, if the condition in the elif is true, then remove the pass keyword and update the value of the low variable by adding 1 to the mid. So low equals mid plus 1. This will extend the search to the right half of the current search area in the list, because if the value is greater than value at middle, it means the value must be in the right half of the current search area. Finally, if the value is not found in the middle, is also not greater than value, and is also not greater than value at middle, then the value must be less than value at middle and be on the left. The else block will handle this. So we remove the break keyword, put an else block in, and set high equal to mid minus 1. So now you can see here, the very first thing it does, it looks here. So this is 0, 1, 2. So then the mid becomes 3, or the low becomes 3. So 3 to 5, you add those, it becomes 4. So then we check the fifth element at index 4, and it's too high. So then we say, okay, well, the mid must be here, and then when we do that, we hit our number. Did you notice the second function call now has the value 354 in the list? The indices. This indicates the binary search is working as intended. This is how it happened. The algorithm first checked 3 as the middle of the initial list. That's what I just said. Since 4 is greater than 3, the search shifts to the right half. It examines the 5 as the new middle. Because 4 is less than 5, it moved to the left, ultimately identifying 4 as the middle of the final range. To test the function call again, call it with for blah 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 blah. And print right away. So I think we can just too many parentheses. Nope. Oh, we're missing a bracket from our list. So we're looking for 10. In this case, it's not there, so it just returns an empty list. You can see the last call print an empty list to further specify that the value is not in the search list. Update the return statement and return an empty list and the message value not found. And notice it returns a tuple because we used a comma here. By default, it says, hey, you want to return items, more than one item? And we're going to put it in a tuple. One final small enhancement that we'll add is also to show that the index is at which the target value is found. So instead of returning path to target in the if statement, add an F string that says value. Okay, so F string. That's not what I wanted to do. There we go. Value found at index 2, value found at index 3, value not found. Oh, we need path to target and. Oh, so instead of returning only. Yay, we're done. All right. So up next, we have this bisect and implement a bisection method. Square root bisection. This one's fun because there's all kinds of opportunities to create a while loop mess, and so I figured out that while loops are dangerous, you shouldn't use a while loop. And so since we in this one here we'll have a number of iterations, maximum iterations, and so we just create a for loop with that maximum. That way we don't run into problems where we never find the thing within the tolerance and ask me how I know. So, all right. Thanks for watching the video. Don't forget to comment, like, and subscribe, and I'll see you next time for our implement the bisection method in our free code camp Python certification in 100-ish days. Out.